All right, we're back. We're starting a new unit. This is actually one of my favorite units. This may be my favorite thing to teach, period, and that is inheritance. This whole unit is about inheritance. It's kind of going to feel like Objects 2.0. So object-oriented programming seeks to make complex software more intuitive by simply modeling real-world objects and ideas. So the whole concept here is that we just try to model the real world as much as possible. And so whenever we get really deep into a program and we're like, how should these things interact? I've got multiple objects. How should they interact? And the answer is always, well, how do they interact in the real world? And that helps explain the interaction. While it is possible for a program to operate using only one class, often several classes are needed as the program becomes more and more complex. With multiple classes comes the need to represent relationships between these classes. Object-oriented programming's ability to model real-world objects and classes and ideas would fall apart if there were no way to model relationships between classes. Fortunately, we can model these things in object-oriented programming. We've actually already encountered a relationship that is extremely common, and that is has-a. Has-a relationships are implemented via instance variables. This is going to be a almost test question. I'll ask this multiple times. How do we represent has-a relationships? For instance, a student has a ID. A student has a GPA. So these things would be instance variables inside of student. And of course, we're going to have things like name as well. A rectangle has a width. A rectangle has a height. Again, these are going to be instance variables. We model has-a relationships via instance variables. This idea works across multiple classes, including the custom classes we make. So here I'm talking about how a library can have books. Okay, this is kind of a class diagram snippet. So I have a class called library. I have a class called book. A book is going to have a author and ID. And we got some methods here. And then we have a library, which if you notice, books is actually a book array. Okay, so this is a snippet of a class diagram. We'll see more of these. They become a little bit more necessary once we get more and more classes, but this is a one-to-many relationship. What are we saying? We're saying one library can have multiple books. It says 0 to 1. In theory, you don't have a library at all. You can have just one book. That just means your array would have a length of 1. But ultimately, we're saying that one library can have multiple books. That's still a has-a relationship, but again, look how it manifests. Instance variables. Okay? A library has a book. Well, multiple books. We see it show up as an instance variable. Okay, I would ask you to take a moment. What are some other has-a relationships that you can think of? Additionally, OOP is capable of representing is-a relationships. Right? In terms of class diagrams, we'll see it manifest as this. We're going to say that student is a person. One thing I like you to quickly notice, that was the key. Been playing too many video games, y'all. I tried a WASD on this. Come on. I want to go back. We'll use arrow keys. One thing I like you to notice is this has-a relationship is more of a horizontal relationship, right? We're saying these things are related, but one is not necessarily above the other. With our is-a relationship, it's more of a vertical relationship. We're saying student is a person. Rectangle is a shape. Give me some other is-a relationships you can think of. Right? There's lots of things here, right? Laptop is a computer. Lamp is a light. In Java, is-a relationships are implemented via the extends reserved word and inheritance. So in order to set up this is-a relationship, I have a class person that exists. In order to show that student is part of this hierarchy, in order to show that student is a person, I'm going to say student extends person, right? This is actual code that would appear to set that up. Don't pay too much attention to this abstract. We'll come back to that. But we're saying that rectangle is a shape using the extends keyword. Extending a class creates a class hierarchy. The class that is being extended is known as a superclass. The superclass, I should say. While the class that is extending is known as a subclass. Okay, so person is our superclass in this hierarchy. Student is our subclass. Other things you'll hear is parent and child, which is going to make sense. We're going to see very soon that you can keep going with this hierarchy, right? There could be things above person, in fact there is, and there could be things beneath student. And the parent-child is very good for describing these things, because then you can bring in words like, grandfather or whatever, grandparent, to describe, one that's up a level above even person. In Java, a class can only extend one class. However, a class can be extended by multiple classes. I'm going to say this again. In Java, a class can only extend one class. That period. A class can be extended by multiple classes. There's a note down here. I'm not even going to mention it because it is way outside of what this class covers. But this statement, despite what this stuff is saying down here, this is still true, period. A class can only extend one class. A class can be extended by multiple classes. Visually, it looks like this. I think the visual representation helps explain it, right? Here I have person. It is being extended by multiple things: student, employee. Okay. Note that student is only extending one thing. Employee is only extending one thing. So a class can be extended by multiple things, but a class can only extend one thing. You can only have one superclass. You can have multiple subclasses. Note that it is up to the subclass to do the extending. The superclass ultimately has no idea what classes are extending it, right? Visually, we're talking about this. This arrow kind of shows it, right? Student is the one doing the extending. And if we go back, think about how it manifests in code, right? It's up to the subclass to actually do the extending. Shape has no reference to rectangle, right? Person has no reference to student. It's up to the subclass to do the extending. The arrow helps convey that. Okay. No, I didn't have to go back. Okay. There could be several levels in a class hierarchy, right? So this is where that parent-child, grandparent thing kind of really pays off. But take a look at this. Person has one subclass, and it's student. Student has one superclass, and it is person. Okay. It's the same thing down here. We would say that student has one subclass. It is college student. College student has one superclass. It is student. What I would not say is that college student is a subclass of person. I would say that college student is beneath person in the class hierarchy, but I would not say that college student is a subclass of person. All right? Take a look at our notes here, right? This is a subclass of student, no mention of person. And the arrows are help conveying this. And this is how it will actually manifest. Student is extending person. College student is extending student. Okay? From a design standpoint, superclasses should be more generic than the classes that extend them, right? Person is a much more generic being, class, than student. Student is a much more generic class than college student. Okay, what is the point of all this? For one thing, we're going to be able to represent ISA relationships. That is something that we need if we're going to make OOP work, right? The grand scheme of this is that OOP wants to represent the real world. And in the real world, we have hierarchies of objects. Okay? But there are programming benefits, and that is what this slide is mentioning. Properties like instance variables and behaviors like methods that are common across multiple classes should be defined in this superclass. Subclasses will inherit any instance variables and methods that are defined in the superclasses above it in the class hierarchy. In our example, a person has a first and last name. Additionally, a person has getters for those respective methods. A student has an ID and a GPA. Additionally, a student will have a first and last name because it's going to inherit these. Because student is extending person, it's going to have these instance variables it defines itself, but it's also going to have these instance variables, right? It's going to inherit them. This is the programming benefit. We don't have to write this code all over again. We get to reduce duplicate code because things like a name are going to be inherited. Likewise, the methods that are in person will also be extended or inherited by student. Let's code this. Right? I'm going to bring up the Intellij. I'm going to make a new project by going to File, New Project. And, I'm going to go next. Next, I need to switch folders. So I'm going to go to my CSA folder. And I'm going to call this project person. I'm going to ensure that I have a subfolder. I'm going to expand my project folder, right click on the SRC and make a new class called person. Right? This is an object. It's going to have some instance variables, most notably something like a first and last name. Those are going to be strings. Okay. The moment that you have instance variables in your class, you can start auto-generating code. With Windows, it's Alt-Insert. You could conversely right-click and, no, maybe not. Alt-Insert, so we get to auto-generate some code. I want to auto-generate a constructor. Actually, let's do like a no-args constructor. So I'm going to say public person. And sorry, I've been coding a lot of JavaScript lately. And let's just give it a generic first and last name, right? Bob Jones. I am going to alt-insert the getters and setters. It's going to ask me which instance variables. You can shift-click, control-click in order to get these things highlighted, and we'll go ahead and insert those. So I have person. This is a good starting point. A person has a first and last name. Those are strings. We'll have a no-args constructor, so we can actually make a person object. And then we're going to have getters and setters for those things. Cool. I'm going to right-click on my SRC, make a new Java class. I'm going to call that one student. In order to establish the class hierarchy, I'm going to say that student extends person. Okay. Right. Notice this is attached to the class header, but this establishes the class hierarchy. Student is extending person. As it stands right now, student is actually going to go ahead and inherit these two instance variables. It's going to have these methods. Okay. Additionally, I would like for a student to have an ID. I would like for a student to have a GPA. And we can make a no-args constructor for our student. Okay, I want to do things like give the ID a value, 1, 2, 3, 4, and we'll say our GPA is a perfect 4.0. Along with these things, I'm going to need getters and setters for ID and GPA. So I'll alt-insert getters and setters. Again, either shift-clicking or control-clicking in order to get all of those. Sweet. So I actually have a class hierarchy, right? Let's make some objects here. I'm going to create a driver. I'll plug in a main method. And I'm going to make a person. Person is a new person. That's going to call the no-args constructor in order to see the values, right? I can print that off. We'll tell this to run. Yikes. Right? I'm calling it a toString, and I haven't made a toString. So we'll hop back over to our person class, and let's throw in a toString. I want this to basically be everything related to my person object. I want it to be the state, right? So we're going to say something like first, along with the first name. I'm going to do a new line after that. And then say last, along with the last name. All right, we'll try that out. Here we go. We see our person, Bob Jones. Let's, in that same driver, create a student. And I'm going to attempt to print off my student. Oh, that's interesting. What is happening there? Okay, so our student is extending person. It's actually going to have 4 instance variables, right? We have the ID and the GPA. We see that there, but we're also inheriting a first and last name. Interesting enough, we see that my student has a name of Bob Jones, but nowhere did I give it that. Right? The only place where that is being set is in the person no-args constructor. So we'll talk about it a little bit later when we dive a little bit more into constructors. But somewhere the constructor has to be getting called. Otherwise, how is that getting set? Okay. Let's go back to the driver, right? Not only are we going to inherit instance variables, and here I'm kind of showing that we are inheriting instance variables because we see a first and last name on my student, right? I could get rid of person completely. Maybe commenting was a better approach, but I don't have person at all. All that's there is a student, and we see Bob Jones, right? So student must be inheriting that first and last name. Additionally, we're going to inherit methods, right? So in Intellij, I'm using my dot operator to call a method. We see things like get GPA, get ID. Those are getters that are in student. So that makes sense. But additionally, there's also get first, get last, right? Those are methods that are defined in person. Student has them as well because it is extending person. Okay, so why is this so cool? Again, 2 reasons, at least 2 reasons. OOP, right? We're able to represent a class hierarchy, a relationship. We're saying that student is a person, but I'm reducing duplicate code because a first and last name is something that a student would have as well. Instead of having to write it in person and then turn around and write it in student, I write it in one spot and let student inherit it. Let's learn a little bit more. The instance variables in the person class are private. Okay, that's going to be a thing. What do I mean? Let's say that I'm in my student and I want to do a toString. Right, we see our first and last name on student. That's a little curious, but I want to write a toString for my student. Okay, well, I'm going to ask the question, how many instance variables does a student have? I see 2 right here, but technically we're going to have 4 because we're going to get these bad boys as well. So when I want to print off my student, I want to see all 4 instance variables, right? I want to see a first and last name. And so I want to see something like first along with our first name. Uh-oh. Right away, Intellij mad at me. And if you scroll over, it says first has private access in person. This was really confusing to me at first when I was basically self-teaching inheritance. I thought, does student actually inherit this thing? Like, I'm supposed to be inheriting it. Yes, we're inheriting it, right? Because we're seeing this Bob Jones student has a first and last name. The thing is, these instance variables are private. When we first talked about private, I was very deliberate with my word choice. I said private restricts access to the class that it's defined in. Okay. So because this is private inside of person, the only place that you can directly access first and last is in person. I'm in student here. I can't do that, right? So the question is, how do we see those things? If a student has a first and last name, students should be able to do something with it, right? So the private access modifier restricts access to the instance variable or method to the class that it is defined in. Even though a student inherits first and last, it does. It has those things. It can't actually access them directly. They are private and only be accessed inside the person class. Now, there's a note here. For one thing, we could put public on these. That is a giant no-no, right? When we first talked about objects, we talked about why. So notice this is fine. Intellij is not mad at me. This is a giant no-no because there's no restrictions here, right? By circumventing methods, you can't put any restrictions in place. So in the case of like a string, there's not a lot of restrictions that you're really looking at. You know, what is a valid first or last name anyway? But in the case of something like an ID or a GPA, right? I don't want a negative ID, probably. I definitely don't want a negative GPA. If you got a negative GPA, you're hurting. Okay. So by going through methods, you can put in logic, like if statements, to make sure that a value that's coming in is a valid one before you save it into your instance variable. If you make an instance variable public, however, you could just access it and change it directly, and there is no chance to put that logic in. So that is a bad idea. Okay, that's why we use private. In fact, the College Board is going to take off points if you give an instance variable anything other than private. Now, what the note is saying here is that in Java, there's actually an access modifier called protected, and it limits access to the class that the instance variable or method is defined in, as well as any subclasses. So we haven't talked about this yet because we haven't had subclasses yet. This is the first time, right? So technically speaking, I'm going to show you this and then ask that you forget it. We can make these things protected, okay? Notice that Intellij is happy. That's because student is a subclass of person. So protected allows the class as well as any subclasses access to those instance variables. Okay. In practice, this is not a bad idea. It's not awful, right? You are basically thinking that your subclasses are going to be good guys, right? They're not going to try to do anything crazy. For this class, you got to use private. Okay. So we're going to proceed as if you got to use private because you have to. So that's going to be a problem when it comes to things like my toString that we're seeing now in my constructor. Why? Well, if I'm here in student, right, we're setting an ID, we're setting a GPA. The whole point of the constructor is to initialize the instance variables, and I actually have 4 of them, right? We have a first name, and maybe I want something other than Bob, but I can't do it directly. That's a yikes. Student literally has instance variables that it needs to be initialized, but it can't access. The solution is to pass this information up as arguments to the person constructor using the reserved word super. What do we mean? Let's plug in a constructor that takes in all 4, or we can play with the no-args constructor that we got. Right? We can initialize ID, GPA as normal, but in terms of my first and last name, I don't have direct access to them. I'm going to pass them up to the constructor above me using super. What do I mean? We're going to say super, and let's go with a different name. Sarah. Okay, this is our syntax. I'm calling a constructor that actually doesn't exist yet, right? So we'll come in here. We'll do public person. I'm going to take in a first name. I'm going to take in a last name. Right? We have our no-args constructor, which does Bob Jones. We're going to have a constructor that takes in a first and last name so that we can be a little bit more dynamic, so that we can say at the point of construction what we want the first and last name of our person to be. Okay, so picture this constructor. I got issues with this toString, so I'm going to comment it out. Let's go back to our driver. Let's start over a little bit. I'm going to make a person. And it's going to be a new person in honor of today's events. How about Tom Brady? Right? So if I print off Tom Brady, or this person, we should see Tom Brady. Okay, so this person constructor allows me to specify a first and last name. We see that here. I'm not using the no-args. In fact, it's gray here in Intellij because I'm not calling it. What that allows me to do now is in my student constructor, I can use this syntax. What I am doing is calling this superclass, right? The superclass of student is person. Whenever we create our student, we're going to call the superclass constructor that matches this signature. What do I mean? A superclass constructor that takes two strings. Here's a superclass constructor that takes two strings. What is it going to do? It's going to set the first and last name. Notice that we have direct access to first and last, despite it being private, because I'm in person, right? In theory, student's not setting this. Student has these instance variables, but is asking person, the superclass, to set them for it. We come back, we're going to do our ID, our GPA, and we should be able to see that. Now, if I flip over to my driver and we make our student, I'm going to call the student no-args constructor. Right? In theory, that is going to set the first and last name. It's kind of interesting here, right? We do see the first and last name of our student, but my toString is commented out, right? I'll even delete it just to kind of prove the point. Commenting out is basically the same thing. So my driver is making a new student. We're calling the student no-args constructor. First thing it does is call this superclass constructor, setting the first and last name to Sarah, Sarah. That's calling this constructor. It saves in those values. We come back, we give our ID and GPA a value, although we don't see it in our toString, and then we're here, where we're printing off our toString. What we're calling, keep in mind, implicitly, is student.toString. This is super interesting to me because I don't have a toString in student. So where is it coming from? Here. This is the toString that I'm using, right? I'm inheriting it from person. So in Java, the constructor of a subclass must make a call to the superclass constructor. Additionally, this call must be the first statement in the subclass constructor. What are we talking about? Okay, so I am making a call to the superclass constructor, right? I'm doing it here. Not only do you have to do that, we'll talk about, moments ago you saw me, I didn't actually do it, so there's some questions surrounding this. But I'm telling you, you have to do it. And it needs to be the first call in the constructor. Here in this example, we see a student constructor. How do I know this is a constructor? There's no return type, right? This is a student constructor. We're trying to set some instance variables, but I'm doing it before the call to the superclass constructor. That is a syntax error, right? So if I take this statement and bump it down, that's a problem. Okay, so the call to the superclass constructor has to happen first. Let's recap. I'm going to come back to some of the issues that we saw in future videos, but in OOP, has the relationships are implemented via blank. That's going to be instance variables. In OOP, is the relationships are implemented via, I will accept inheritance or extends, right? Inheritance is kind of the concept. Extends is the literal syntax. A class that extends another class is known as a subclass. I would also accept a child there. True or false, a class can have multiple superclasses. This is false. Okay. True or false, a class can have multiple subclasses. This is true, right? The best way to kind of explain this is looking at the visual. This one here, right? Person has multiple subclasses. Student only has one superclass. Employee only has one superclass. A subclass constructor must call the superclass constructor. That is true. We're going to talk about why I was able to get away with not doing it earlier, but this is actually true. The call to the superclass constructor must be the first statement in a subclass constructor. True. This is a syntax error if you do otherwise, right? Here's the call to the superclass constructor. Person is the superclass of student. So this is the first statement. That is the end of our recap, and that is going to be the end of our video. We got a lot more to cover with this. I'll see you in the next one.